Welcome to what I feel will be the final video for section 3.7, and most of this will be word problems. We begin right where we left off, example number 13. Number 13 asks, what are the intercepts of this graph? 4 cosine squared of x minus 3 on the interval between 0 and 2 pi inclusive. Well, in order to find the x-intercepts, that means the y value is equal to 0, so all we have to do is set this equal to 0 and solve. So this is really no different than what we have been looking at in the past. So the first thing I will do is add 3, divide both sides by 4, and then take the square root of both sides. Do not forget the plus or minus, and so it will be plus or minus the square root of 3 over 2. Now, cosine will occur 4 different places because we have both the positive and the negative, but the reference angles will be the same once we find one of them. So where does the cosine of x equal root 3 over 2? That's at pi over 6. And so each and every one of these reference angles will be pi over 6, but that's not what we're going to name them. We are going to actually determine the real names of them. So x in this case might equal pi over 6. It might equal this angle right here, which is 5 pi over 6. It might equal that angle right there, which would be 7 pi over 6, and it might be this whole big angle right along over to there, which is 11 pi over 6. And there are the 4 x-intercepts that we might run into. Examples 14 and 15 uses Snell's law, which we have looked at in the past, but it was given to us in a particular way. We actually get Snell's law now, and each one of these is just a matter of plugging in what we know and trying to solve what we don't know. And so we're going to make sure that we are in degrees in our calculators. And just reading in the information, light travels at 2.99 times 10 to the 8th meters per second. And so all we need to do, and that's the velocity, and so all we need to do is put that into Snell's law, which will be the sine of 43 degrees, which is given in the problem, over the sine of the 33 degrees will equal 2.99 times 10 to the 8th over x, because that's what we're trying to find, the speed in the second medium. And understand this is meters per second, so this will also be meters per second. We'll just have to make sure that we do that label. Then it's just a matter of doing cross multiplication. X sine of 43 degrees equals 2.99 times 10 to the 8th times the sine of 33 degrees. And then if we divide both sides by the sine of 43 degrees and put it into our calculator, we end up with 2.39 times 10 to the 8th. What? Label? Meters per second. Same thing can be done with example number 15. Just plug it in, do the cross products, and then we will have it solved. Using the information given in the problem, we have sine of 84 degrees over the sine of 75 degrees equals 2.99 times 10 to the 8th over x. Doing the cross products and solving for x, we get 2.90 times 10 to the 8th meters per second. The last two examples, and I'm throwing out the last one. So we only have two more examples in this particular section. Example number 16. We have the function I of t is equal to 40 times the sine of 60 pi t minus pi over 2. And it represents the amperes. And we want to find the smallest value of t for which the current is 20 amperes. Well, reading the information, I represents the amperes. So what we need to do is we need to say, okay, 20 equals 40 sine of 60 pi over t minus pi over 2. And understand that since they said the smallest, then all we have to do is find the first answer we come to, and then we're done, because that will be the smallest. So we're going to divide both sides by 40, and that gives us the sine of 60 pi t minus pi over 2 is equal to 1/2. Now, even though this seems like a monstrosity, and it really is, all we have to do now is to take the arc sine of both sides. When we take the arc sine of this side, we have 60 pi t minus pi over 2. And we only need to worry about the very smallest value, which would be that value right there. Where does the sine equal 1/2? That would be at pi over 6. Now all we have to do is solve for t, because that's what's being asked. So now we have to add pi over 2 to both sides. And pi over 6 plus pi over 2 is 2 pi over 3. And then divide both sides by 60 pi. And when we take 2 pi over 3 divided by 60 pi, we get 1/90th. And according to the problems, t is given in seconds. So it's 1/90th of a second. Now I do want to warn you that the problem does say round to 3 places if necessary. It was not necessary, and nor was it one of the exceptions. So the answer is 1/90th. And then finally, we get example number 17. A mass hangs from a spring which oscillates up and down. The position P in feet of the mass at time t in seconds is given by position is 4 cosine times or of 4t. For what values of t when t goes between 0 and pi, so we need to look for all of them, will the position be 2√2 feet? And we need to find exact values. Do not use a calculator. Now notice we only have to go from 0 to pi. So normally we would go 4 times around. But that's if we wanted to go from 0 to 2 pi. So since we only want to go halfway, normally we'd go 4 times around. This time we only have to go 2 times around. We only have to go half as far because we're only worried about half as much. Instead of 2 pi, we're only interested in pi. So we need to know the position is 2√2. So 2√2 equals 4 cosine of 4t. Divide both sides by 4, and we get √2 over 2 equals the cosine of 4t. Well, cosine is positive in quadrants 1 and 4, but the reference angles will remain the same, and we only have to go around twice, which is a good thing. Where does cosine equal √2 over 2? Well, the reference angle is pi over 4. And so this angle would also be pi over 4, but that's not what we're going to call it. So now what we're going to do is we're going to say, okay, 4t is going to maybe be pi over 4. Or 4t might be going all the way around to here, would be 7 pi over 4. Or 4t might be go all the way around and end right here, which is 9 pi over 4. Or 4t might equal go all the way around and end right here, which would put us right at 15 pi over 4. And then divide everything through by 4, so that t might equal pi over 16. T might equal 7 pi over 16. T might equal 9 pi over 16. Or finally, t might equal 15 pi over 16. And just to make sure we've done this exactly as we needed it to be, 15 pi over 16 is still less than pi. And so there are the 4 possible answers that we needed to find.